Hello everybody, and welcome back once again. We're at the Voice Peering Forum, June 2008, San Francisco. I'm Hunter Newby, and I'm joined by Mr. Pankaj Shroff, who's the Chief Applications Architect at Sonus Networks. Pankaj, thank you for joining us.
Thank you. Thank you for having me.
Please do tell us a little bit about Sonus Networks.
Sonus is a large equipment manufacturer for telecommunications infrastructure. And Sonus is a full portfolio of equipment from access to applications. We play in the world's biggest markets. We have 6 out of the top 10 carriers as our customers, and we run some of the world's largest IP voice networks, or rather our equipment runs some of the world's largest IP voice networks. For example, we carry about 12 billion minutes on wireless networks within North America itself per month, and over 30 billion minutes a month worldwide.
So that's really impressive. 6 out of 10 for Sonus. How old is Sonus? Company?
Sonus is 10 years old, and we are a public company.
Nice. So, in terms of application development, obviously you're the Chief Applications Architect. So, what are some of the critical applications that you have today, and also what do you see being developed here in the near future?
Absolutely. So, my role at Sonus as a Chief Applications Architect is to focus on essentially trying to give a strategy to the applications program at Sonus, and also to the platform that lies underneath, which is IMX. At IMX, our application strategy focuses around IMX, and it is an application development platform, and at the same time it's a service execution platform. And it really provides carriers an opportunity to kind of bring the Google Labs model to the carrier environment, if you will, and create applications rapidly and deploy them and try them out in smaller sets or targeted towards smaller sets of audiences, and then depending on the hit or success ratio of applications, they can then ramp it up using the exact same equipment or infrastructure.
Wow.
So that's the key benefit of Sonus's IMX platform.
It's the flexibility for them to be able to create and deploy.
It's the flexibility, it's the scalability, and it's the high availability that we carry with our carrier DNA, if you will.
So what goes into that specifically from an applications point? I mean, what do you need to give them as a starting point to have them have the ability to create on top of it?
That's a great question. So, in order to really leverage this rapid application mindset, the Google Labs paradigm, like I said, we have to be able to rely on developers. So there's about 3 to 4 million Java developers, for example, out there. Right? And for a developer that's not a telecom expert to be able to create a service that's immediately scalable and fault tolerant, the idea is, in the IMX, the idea is to expose the capabilities of that kind of infrastructure using APIs that are immediately familiar to those types of developers. And so what we've done is we've taken the SIP Servlet API, which is a standards-based API, and we've implemented that on our platform so that Java developers or folks that are not telco experts can develop applications or services using a servlet programming model which is immediately familiar to them, and we've then extended those APIs and exposed, for example, a fault tolerance or high availability API, or a billing information API, or a subscribers profile API, in the same vein as the SIP Servlet API. So it's again very familiar to them, and they don't have to learn the 20, 30, 50 years of research that has gone behind high availability.
So you let them come at it from their perspective, and you insulate them from all the other stuff.
Absolutely. We provide an abstraction layer to them so that they can create or innovate at the speed that they're used to innovating, and then let the infrastructure or the application platform, which is the IMX, take care of high availability and failover and redundancy and performance.
So those are the key elements that you give them that are essentially the fundamental building blocks.
Absolutely.
So there they are, and then they can play the level above that.
Exactly. And we don't just say Java, we provide them multiple layers of abstraction at that point, and we provide, so for example, we support CCXML, and we are implementing web services in our platforms so that they can use languages that they're already comfortable with.
Right. Do you ever incorporate any of the things that the developers do into your core package?
Absolutely. So what we've done is, so there's a couple of different models there. One is when we develop custom applications for our carrier partners or our customers, we tend to retain IPR. Depending on the way the deal is structured, we are willing to share IPR or have the customer completely own the IPR. And in cases where we do own the IPR, those types of services are bundled inside the application and then offered up as, shrink wrap building blocks.
For the purposes of the people watching this one day, explain what IPR is.
Okay, IPR is just intellectual property rights.
Right.
So that's all I meant.
There's a lot of acronyms in this business.
Absolutely.
And IP means a lot of things to people. I just want to be very clear.
Very good, very good question.
Intellectual property rights.
Yeah.
So that's really interesting. I've heard some stories in the past about the hardware world, particularly voice, and sort of asterisk, so the asterisk phenomenon, specifically in voice over IP. And if I could draw a parallel or an analogy to Linux and the other old server models, and then open source, and then we obviously saw